Hello, and welcome to Engineering Economics. We're going to talk about profit and loss now, because what we do as engineers has a business impact. And so we're going to get a little bit into business so that when you get into your companies, you can talk to the business people. You can you have a common frame of reference to be able to discuss cost benefit analysis with business people. And by the way, as you guys are studying engineering, just remember business colleges, they love engineers who switch to business. MBAs, Harvard, Stanford, because you guys understand numbers. When you get out of 4 years of engineering, you're going to know math inside and out, and you're going to be really good at business, which is why MBA colleges look very favorably on engineers. So we got to ask what money is worth at a particular time reference, because a dollar today is not worth the same as a dollar 20 years ago. And we need to factor in things like interest, inflation, and so forth. So let's consider a simple example. We're not going to consider interest or inflation. It's just how much does a Ford versus a Chevy cost? How much does it cost to operate it? How much does it cost to maintain? And salvage cost is when you sell it used at the end of its life, how much do you think you can get for it? And the simple analysis is just add up all the totals for the Ford and add up all the totals for the Chevy and compare them, which is what we do next. So the total 5-year cost for the Ford is $21,500. The total 5-year cost for the Chevy is $21,250. So this would be just for $250 worth, which there might be a lot of other factors that would cause you to choose a particular Ford model over a particular Chevy model rather than money, because in a total cost of a car, this isn't much. You'd go into your decision matrices and decide on other factors. Maybe the Ford has a higher payload, it can be more productive for your business, and so forth. But just on a simple cost basis, just looking at this simply, the Chevy it would be the decision. So if you put cost in the decision matrix, Chevy would be a higher value than Ford. What we do is we plot this on a cost flow diagram for a project. Now, unlike a car where you just have expenses, no incomes, a project might be expected to generate income over its lifetime, but it would also incur costs. You have the initial costs, and then you have its salvage value, which is final value income. We need to reference everything to a single point in time, and we're going to learn how to do that. So here's just a cash flow diagram. The trouble with a cash flow diagram is it's hard to judge what's the total inflow and outflow is. When you add everything up, the cash flow diagram doesn't show that at the very end. But it shows you what happens year by year or month by month, whatever your time period is. How much income you're gaining versus how much you're spending. So, is it a correct analysis? It's a good visual tool to help you understand how you're going to expect your bank account to fluctuate over time. But as far as analyzing whether it's a good decision or not, maybe not so great. We need to consider the time value of money. $1 10 years is not the same as $1 today. You earn interest on income, and there's inflation and other things. And it's variable. We need to figure out equivalence. And we're going to learn how to do that. We're going to learn how to take all these numbers and make them equivalent to a certain point in time. There is a tension between customers and suppliers. If you do everything all at once, say the customer pays, they get their product immediately, and that's all there is, then you got a very simple cash flow diagram. But the customer knows we earn interest. So if the customer pays in advance, they want to get a little break because you're keeping their money. In contrast, the supplier wants to get the customer's money now, and if the customer wants to pay late, the supplier wants to get a little interest for allowing the customer time payment plan. You're probably familiar with that. You have to pay interest to use a credit card, and so forth. So we need to learn how to adjust for the rates of inflation. We have a minimum acceptable rate of return. And the way we do that is we say we compare investing money to borrowing money for equipment that's going to go into our project and the return on that project. And we ask if the company keeps the money and puts it into their investment portfolio, and that investment portfolio, say, returns an average of 7%, then your project has to return better than the minimum acceptable rate of return is going to be 7% for your project. If it can't meet 7%, then the company's not going to spend money on your project. If it can, they will. So we need to understand interest, simple interest. You have $100, 5 years to pay. It accrues at 10% per annum. So at the end of 5 years, you're going to owe $150. $10 times 5 years. And here's the formula. Very simple formula. F for future value, P for principal, I for interest rate, N for number of periods. Interest rate per period, number of periods. So it might be interest rate per month, interest rate per day, etc. Number of periods, 365 periods. Or if it's interest rate per month, then number of periods is 12 months times 5 years, or 60 months, and so forth. In this case, it's years. So N would be the number of years, interest rate would be 10%. And there we have the calculation. Now, compound interest, the difference. How does compound interest work? So at the end of the first year, you get a loan for $100. You're going to owe $10 after the first year. So at the end of the first year, you're going to owe $110. But now they say, well, we've actually loaned you $110. So for the second year, you're going to pay 10% on the $110, not just 10% on the $100. So that's $11 on top of your $110 to make it $121 you owe at the end of the second year. 10% of this is $12.10. Add $12.10 to $121 to get $133.10. 10% of $133.10 is $13.31. Add $13.31 to $133.10 and you get $146.41. And then finally, 10% of $146.41 is $14.64 plus $146.41 will sum to $161.05. So at the end of 5 years, you would owe $161.05, where the simple interest you'd only owe $150. Let me talk about formulas just a little bit. This formula looks real similar to the previous one, but you might be confused with terms. Let me give us a nice dark red color for the marker. So this may be called F for future value instead of amount, P for principal, or P for present value, R for interest rate, N for the number of times compounded per year. The previous formula used interest rate per period, so let's connect the two. So you might say A equals present value 1 plus I, interest rate per period, to the raised to the power of the number of payment periods. Well, N, capital N, is going to equal little n t. Little n number of periods per year, T time in years in this case. R over N, little r over little n equals I, interest rate per period. And finally, the rate R equals 10%. You have to write it as a decimal. You can't use 10 in this formula. You got to write it as a decimal. And that would be the number that goes into this formula, not 10, 0.1. Okay, good time to stop. We'll stop this video here and pick it up with the next video.